Okay, I tried to draw this one all slick-like, but it only let me do one of them slick. Anyway, I'm trying to find the area inside this thing. Again, at Carson 24, they don't give you a picture. They just tell you this is what it is. I think the easiest way to do this now, well, there's a couple ways to do this. You could figure out the area of this little, I don't know what you call this little doorstop kind of piece, and find out what, multiply that by 2 and subtract from the square. The way to do that would be square minus quarter circle, which actually isn't bad. You could also cut this thing in half, which we seem to be doing a lot, and then find the area of one of these little sunrise pieces, and then just multiply that by 2. And then you have, which is, sector minus triangle. I'm going to do that one just because we have been doing that one so much. So I'm going to go this thing, like the entire quarter circle. Notice both ways you had to find the quarter circle. The quarter circle here is 1/4 of a circle, pi r squared. We haven't had a lot of arc length in these questions. Okay, which is 1/4 of 64 pi, which is 16 pi. Okay, and then I'm going to subtract from that the triangle that's 8 by 8, which is 1/2 base times height. I mean, they're both not that bad. Base times height, which is half of 64, which is 32. I'll subtract those, and I'll get 16 pi minus 32. Now, 16 pi minus 32, that's the area of this much right here. So I have to double that for my final answer. 16 pi minus 32 times 2. The book, whoops, 32. The book answer says 32 pi minus 64. Same thing. 32 pi, if you distribute that to 32 pi minus 64. Okay. Again, I couldn't draw this real slick-like, but I think you get the idea. That the one circle, the center of one circle is on the other circle. We basically have one of these kind of things. I'm trying to find the area of all of that stuff now. Again, I think it's going to be best to cut into these little sunrise pieces. These have been serving us well. If I think about one of these, let's think about the this circle first, and actually this one as it is part of that circle, because then it's like this sector minus this triangle, and then we'll just multiply that by 2. There might be other ways to do this. None of them are striking me right now. Actually, no, we could do a little equilateral triangle up here, and then I have little tiny sunrise pieces here and here. I could add those on and do some funky stuff. I think this is going to be the easiest. First of all, I'm pretty sure this has got to be, not pretty sure, I'm exactly sure. This has to be a 120-degree angle. Why is that? Well, we've done this before where we've got these two circles intersecting like this. This is a radius, this is a radius, this is a radius. They're all the same. This is an equilateral triangle if I were to draw it here. So this is 60, so this is 60, so this is 120. I've got 120 degrees of a circle. So the sector here is kind of facing that direction. This area is going to be 1/3 of the circle of the pi r squared, and r is 6. So 1/3 of 30, we just got this one a lot. This seems to be 12 pi. And I'm going to subtract the triangle. It's kind of facing this direction. Okay, this is going to be a little trickier. This triangle, this thing is 6, this thing is 6. This would have to be 3. Because it's 30, 60, 90. The height, I guess you'd call it, of this triangle is the 3 square root 3. For, from here to here is 3 square root 3. So the whole thing, the whole height, sorry, I guess I would call it the base. The whole base is 6 square root 3. Times this little height, which would be 3. Half times 6 times 3 is 9 square root 3. So that was sector and triangle. I'll subtract those. 12 pi minus 9 square root 3. That's 1/2 of the area I need to find. I basically found this thing with the red squiggle in it. I need 2 of those for my final answer. This is perfectly fine. I don't know what the book says, but this is the calculation you'd use if you wanted decimals. You'd do that. The book says 24 pi minus 18 square root 3, which is perfectly fine. Okay, there we go. Okay, in this one they want us to find all of this area. They say the radius of the square is 2. I still have a problem with that word, but okay. Radius of the square is 2, which is what I've got marked here. It's that thing there. It's not the radius of the circle, I don't think. No, it's not the radius of the circle. It's the radius of the square. Okay, so that's 2. I don't think it's hard to believe that what we're talking about here is a 45, 45, 90 triangle. So if that's 2, this is also 2. This side of the square is 2 square root 2. So that's the side of the square. That's going to be kind of nice to know. I think we're going to want to know we're gonna split these into these little same kind of, what these things are called, segments of circles, like this one over here, like that one over there. So I have this little one here. For this, I'm gonna want to know, well, how much of the circle is that? I need to know basically this sector. Oh, here we go. That'd be the center of the circle, right? There's a radius. There's a radius. This is 90 degrees. So let's do sector. I'll take sector minus this triangle. Sector here, well, what's the radius of this circle? Well, the side of the circle is 2 square root 2. This is half of that, or this is half of the side here. So, first of all, I'm talking about a quarter of a circle. I'm talking about a quarter of a pi r squared. But the radius here is just the square root of 2. So, well, this nice thing about square root of 2, when I square it, it's 2. So I have half of pi all together here. That's the area of that little sector. I'm going to subtract off the triangle to get the remaining sunrise here. The triangle is, again, this is square root of 2. This is square root of 2. This little piece here. So this is base times height times half. Half times base times height. Again, this is 2 divided by 2. It turns out to be 1 area of that triangle. So the area of the little thing like that is square root of 2. Sorry. It's pi over 2, or half pi, minus 1. And how many of those do I have? 1, 2, 3, 4, 5, 6, 7, 8. If we cut this one in half too, I've got 8 of those little pieces. So I've got 8 times this. I like this answer. This is your exact answer. What does the book say? The book probably says 4 pi minus 8, which is perfectly fine. It's exactly what they say, 4 pi minus 8. Now again, there's a number of ways you could have chopped that up and done it. That's the way I have. You notice what I'm trying to do for consistency and maybe make it easier is that whenever there's a chance to cut these little curvy things up, I cut them into one of these shapes. I cut them into a piece of a circle that's outside a chord. And that area is always found out by taking the sector minus the triangle. And that's been good to us. This construction is actually very fast and sort of fun. You just take any old radius, make a circle, move the compass to any point on the circle. Oh, it's hard to drop this right where I want to drop it. Actually, it might work better if I do it this way. Let's try this. Okay, and then I draw a circle. Whoa, I didn't need to draw it out that far. Fine. Move this to here now, and I do it again. You see it start to come together yet? Okay, I just keep, whoops, didn't mean to draw out there. Keep doing that. It's very pretty. Okay, it should keep lining up on itself. Of course, I have a perfect compass. I guess I don't have to be so good that I actually drop it perfectly. So there's a little bit of human element here. Can I move this without? Oh no, don't do that. Oh no, I changed the radius. I changed the radius. I didn't mean to change the radius. Don't change the radius. Oh, this is maybe not going to work now. Okay, I meant to swivel the thing without drawing. I thought there was a way to do that. Oh, there you go. You just, oh, okay. There we go. And then, is there one more to do? Yeah. See, I'm a little bit off already. Human error. Oh, missed one. Oh, I just didn't connect. I just didn't extend this one far enough. Okay, so it's kind of easy. It's not really easy. All right, so there's that thing. I'm supposed to find the area of all of the stuff in the flower, of course. Yeah, coloring's fun, but not when you're in a hurry. Okay, so do all that stuff, and I know that the radius is 6. All right, so that thing. Notice how I strategically do it right there, because guess what we're going to do? We're going to split these up into all these little things. The radius of any one of these circles is 6, remember, because I didn't change this the whole time. So radius is 6 from here to here also. And all of these angles, if you don't believe this, I mean, look, you've got 6 points perfectly around the circle. All these angles, like from that one to the next one, or from here to here, all of this stuff is 60 degrees. We've got equilateral triangles all over the place. We have a regular hexagon if we connect all that together. So, yeah, so in any one of these, I'm going to do segment of a circle, which was sector minus triangle again. So, just to find this one here, I'm going to take 1/6 of a circle, 1/6 of a pi r squared, which is the whole sector. 1/6 of pi r squared is just 6 pi. By the way, we're finding out like this shape. And we're going to subtract out the triangle. And the triangle is a 6 by 6 by 6 equilateral triangle that was in that sector. The sector went from here to here all the way around here. So that was the sector. And we're going to take out the triangle, which was this much of it. tell what I'm talking about yet. Taking out that much of it to be left with the part that's outside. Now you can't really tell what I'm talking about. Anyway, done it plenty of times. Area of the equilateral triangle is half times base times, whoa, height. Well, that's just 3 times the square root of 3 in our 30, 60, 90 world. 3 times the square root of 3, and that is 3 times the square root of 9 square root of 3. So each one of these little halves of this area here is 6 pi minus 9 square root of 3. Sorry, I had to pause for sneeze there. That would have been really bad. All right, so how many of those little things do I have? It looks like I have 12. There's 2 in every petal. So what I have total here is 12 of those. 6 pi's minus, come on, let me draw that, minus 9 square root of 3. And I like that answer perfectly fine. I'm sure the book has something like 72 pi minus 108 square root of 3. That's exactly what they have. Okay, great. Okay, this is a little weird to see. Here I've made 3 circles that are congruent to each other because I can do that because I've got software. Tangent to each other means that all 3 of them kind of do something like this. This is kind of hard to see, but it's really easy if you've got, you know, real coins move around. I'm sorry, I said coins, thinking you could do this on your own. If you thought about coins that are sliding around on a table or something like that, that's kind of too fat. Right, so this is the area I'm looking for. Well, what's cool about this is you could actually think about connecting these radiuses together. The radius of this circle is 6, so is the radius of this circle. So from one circle to the next is exactly 12. Center to center. Center to center here is 12. Is that about right? And center to center here is 12. And there's an equilateral triangle, kids. What I really have here, if you look at it this way, they've got equilateral triangle minus 3 sectors. So this really turns out not to be that difficult. This is 6, this is 6, so the whole thing is 12. Area of the triangle is half times base. Entire triangle base would be 12. The height across here, or like the height across here, would be 6 square root of 3. We've done that enough by now. So the area of the whole triangle is 36 square root of 3. And then let's find out one of these and multiply it by 3. So the area of 3 sectors is going to be 3 times 1/6 of the circle. That's because that's 60 degrees. That's 1/6 of the circle because these are the equilateral triangle. So that's 60 degrees out of 360 of pi r squared. So 1/6 cancels. I have 6 pi times 3, which is 18 pi. We're getting the same numbers a lot here. So all we have here is 36 square root of 3. It's actually one of the easier calculations. It's just hard to see and hard to realize, oh yeah, if I connect those together, that's it. And this point is nice. It's right at the end of this little pointy thing in the middle where the circles sort of chop it off. All right, so I'm going to check the book really quick, see if that's how they answer. They do. 36 square root of 3 minus 18 pi. Okay, there was your homework questions. I'll try not to have to do this again because this was no fun for me, really, to spend all this time doing this. But it was my fault because the quiz is so hard. I'll see you on Friday, and we will talk quiz repair. See you then.